Welcome to my project buzzer.com. Let's be going to see about the mitigation of lower order harmonics in a grid connected single phase PV inverter. I am going to explain the concept of this process. A novel design of inverter current control that mitigates lower order harmonics is presented here. An adaptive harmonic compensation technique and its design are proposed for the lower order harmonic compensation. Recursive least square adaptive filter is used to find harmonic in the grid current. A simple single phase grid connected photovoltaic inverter topology consisting of a boost section, a low voltage single phase inverter with an inductive filter and a step-up transformer interfacing the grid is considered. A proportional resonant integral controller and its design are also proposed for eliminate DC component in the system and also introduces even harmonics in the grid current topology. This is the flow diagram of our process. First we construct the MPPT model. MPPT is nothing but maximum point power tracking. In this module, photovoltaic panels, that is solar panels, have a well-defined operating point that delivers maximum power, and MPPT actively seeks its operating point. This is a special case of optimal control. A PV cell can be modeled as a current source and a diode. Maximum power is delivered near the knee of the curve. The next one is the single phase inverter. In single phase inverter, DC to AC converters are known as inverters. The function of an inverter is to change a DC input to a symmetrical AC output voltage of desired magnitude and frequency. This is general single phase inverter operation. The next step is the PRI controller. In PRI controller means the proportional resonant integral controller. The interaction between the PRI loop and the adaptive compensation scheme would not affect the stability of the system. To show the effectiveness of the PRI controller, an offset was added to the control loop. PRI controller eliminates the DC component. PRI controller has been verified experimentally and the results show good improvement in the grid current THD once the proposed current control is applied. And the next one is the PR controller. A proportional controller will have the effect of reducing the rising time and will reduce but never eliminate the steady state error. By only employing proportional control, a steady state error occurs. Then last we apply the RLS filter for filter compensation. The method of least squares will be used to derive a recursive algorithm for automatically adjusting the coefficients of a tapped delay line filter without invoking assumptions on the statistics of the input signals. This procedure, called the recursive least squares algorithm, is capable of realizing a rate of convergence that is much faster than the LMS algorithm, because the RLS algorithm utilizes all the information contained in the input data from the start of the adaptation up to the present. Now let's be going to see about the implementation of this process. Let's now discuss about this process. This is the MATLAB command window. First we design the constant and subsystems. Give as usual 3-phase inverter and the MPPT block is designed. MPPT means the maximum power point tracking. In MPPT, two inputs are given, that is voltage and current, and the output is extracted from the MPPT block and the output is connected to the single phase inverter. Then the inverter model, that is solar PV model, is converted to the designed PRI controller. Then the controlling result is given to the voltage is given to the RLS filter. Then finally we get the result from the recursive least square filter. From that we reduce the harmonics. It's the major concept of our paper. 3-4 cells is given to the MPPT block. In MPPT, separate devices are used and extract the voltage and current value. IGBT devices are given to reduce the number of switching devices. Then for inverter, pulses or whole gate pulses are collected into a single PWM generator. Then for the IGBT device, the input is given to this processor. Finally, from that we reduce the harmonics and by using RLS filter. From this we conclude that the inverter current control of a grid connected single phase photovoltaic inverter has been proposed. High quality of the current also injected into the grid. The proposed method uses an RLS adaptive filter to estimate a particular harmonic in the grid current that needs to be alternated. To avoid DC biasing of the transformer, a novel PRI controller has been proposed and its design has been presented. Thank you.